Hello everyone. So in this video, we will understand about one important theorem called Bayes theorem. And the theorem is given below. Let A1, A2, A3 and so on up to AN are n mutually exclusive and exhaustive events of a random experiment. Let capital B be a common event which is common to all the above events. Then the probability of AI means any of these A's. It can be any of these A's, any of these events. Given that the common event has already happened, is equal to probability of AI multiplied by probability of B given AI, the whole thing divided by summation of I equal to 1 to n probability of AI multiplied by probability of B given AI. So this is the theorem. Now let us understand how it is arrived at, or the proof of this, right? Let's move to the next slide. Yes. So in order to prove this theorem, what we are going to do is we are going to assume only 4 events for convenience sake. So we are assuming A1, A2, A3, A4 instead of till AN, instead of considering AN, we are considering it as 4 events, A1, A2, A3, A4, which are mutually exclusive and exhaustive events of a random experiment. So let B be a common event, common to all the above events. So here, if you look into this picture, there is a box which is considered to be the sample space. I can call this as the complete sample space. Okay. And this sample space has got only 4 events. One is this A1. Let me just mark it with some different color. This is our A1. This area is our A1. Okay. Then A2. Let's choose some different color. We'll consider that as A2. Means this portion is A1, this portion is A2, and then we'll also have another color to distinguish. Let's take this blue color. This, whatever I'm shading now, this is our A4, means this portion is our A4. That means the balanced portion is our A3. So we may note that all these are disjoint. So A1 is nowhere intersecting with A2 or A3 or A4. Similarly, A2 is nowhere intersecting with the other 3 events. Similarly, A4 is not intersecting with any of the other events. So naturally, A4 also is not intersecting with any of these other 3 events. But if you look into the common event B, which is denoted by circle, that is actually intersecting, or it is common to all the 4 events. So let me show it in red color. So we may notice that this particular circle is passing through all the events, means it is common. This particular event can happen in joint with any of the any of these 4 events. That is what it means. Now, one thing is clear, this particular circle is nothing but our B, right? Oh, sorry, I should not have written there. Let me rub that. I can write it somewhere outside, right? I will show. This is the circle. So that is our common event B. Okay. Now, if I have to write this B in terms of A1, A2, A3 like that, before that, what we will try to do, we will understand this particular thing. What is this portion? Means this portion, this red color, wherever I'm moving my mouse, and then this yellow color. What is this portion? It is basically A1 intersection B, right? Now, what is this portion? That is this red color and then this green color. What is that portion? That is nothing but A2 intersection B, right? Then what is this portion? That is this red color and then this blue color and then this yellow color, right? What is that portion? That is A4 intersection B. And what is the balance portion? Balance portion, what I mean is this yellow, this green, this red, and this blue. That is nothing but A3 intersection B. So that is that particular portion. So what I can do is I can represent this entire circle B in terms of all these things. This, right? That's what we are going to do in the next slide. So I can write now B, that is set B as, I can write set B as A1 intersection B, then union A2 intersection B, union A3 intersection B, union A4 intersection B. So I can write B in terms of A1 intersection B, A2 intersection like that, right? So let us go back again to this previous diagram. If you look into this portion, that is A1 intersection B, is disjoint with A2 intersection B. It is disjoint with A3 intersection B. It is disjoint with A4 intersection B. Means all these are disjoint sets, which means that these are all mutually exclusive events. So if I write it in terms of probability, so I can write probability of B as probability of A1 intersection B union A2 intersection B union A3 intersection B union A4 intersection B. Now, one thing is clear, these sets are disjoint. Which one? A1 intersection B, A2 intersection B, A3, all this are. That means these are all mutually exclusive events. So I can rewrite this as probability of A1 intersection B plus probability of A2 intersection B plus probability of A3 intersection B plus probability of A4 intersection B. So it can be written like that. Now I can have a summation I is equal to 1 to n probability of AI intersection B, right? So because what is varying? 1, 2, 3, 4, that is varying. So I just put suffix I and then I'm varying it here. I equal to 1 to, I'm sorry, I should have written here as 4 instead of n because we took only 4 events, right? So this, now let us see how do I write now. How do I write probability of AI intersection B, right? So one thing is clear that I have to use the multiplication rule of probability if these two events are dependent, because it is dependent because there is an intersection which is happening, which means I can write this as probability of AI multiplied by probability of B given AI, right? Clear. Now, how can I write? Okay, this is one part. So that means in this summation, I can substitute this. I can say, therefore, probability of B can be written as summation I equal to 1 to 4. So whatever is expressed inside the summation, I will replace it with this. Means I can write it as probability of AI multiplied by probability of B given AI. So this is one part. Now, let me move on to the next slide to continue further. Let me write now, what is probability of AI given B? So, by the formula of conditional probability, how can I write this? I can write this as probability of AI intersection B divided by probability of B. Right? Now, let us go back. What is probability of AI intersection B? Here it is. It is probability of AI into probability of B given AI. So numerator is probability of AI into probability of B given AI. Now, what is the denominator? Already we evaluated previously. It is this. So if you look into this expression and this expression are the same, except that here there is a summation. So let me write summation I equal to 1 to 4 probability of AI into probability of B given AI. So whatever we derived, it is meant for 4 events. So in general, if it is n events, if there are n mutually exclusive and exhaustive events of a random experiment, then I can generalize this. AI given B is equal to, same thing I will write, except that in the denominator, instead of writing 4, I will replace that 4 with n. That's all. So that is our Bayes theorem, which has got numerous applications in various fields, right? So we will see in our subsequent videos some of the problems where we use this Bayes theorem, right? So in case if you find this video to be useful, I request you to like, share, and subscribe to my channel so that you get regular updates on my videos. In the meantime, I thank you all. Take care.